This video seminar is about the flexible manufacturing system. Flexible manufacturing system is a highly automated system which consists of many workstations interconnected by automated material handling and storage system, which is controlled by a distributed computer system. It is called a flexible system because it can process a wide variety of parts at different workstations simultaneously, and according to the classification based on production quantity, FMS is suited for the mid-variety and mid-volume production range. What makes it flexible? These are three capabilities that makes a manufacturing system to be flexible. The ability to identify and distinguish among different part styles processed by the system, the parts to be machined by different workstations and different tools are identified, and then each operations are changed for each part, and then the physical setup is changed so quick. This makes the entire manufacturing system flexible manufacturing. Then there are different tests for flexibility. To mention a manufacturing system as a flexible manufacturing system, there are 4 reasons that it should qualify. The first one is part variety test. It should be able to process different part styles. The second one is scheduled change test. It can accept changes easily and quickly. The third one is error recovery test. It can recover quickly from any error in the equipment. And the fourth one is new part test. If all these tests gives a positive response, then the system is considered flexible. Then these are the different types of flexibility in a manufacturing system. The types are machine flexibility, which is based on a flexibility of a workstation to a wide range of production operations and part styles. This flexibility depends on factors such as setup time or changeover time, ease of machine reprogramming and part programming, tool storage capacity, skill and versatility of workers in the system. The next one is production flexibility, the range or universe of part styles that can be produced on the system. And the factors that depends on this flexibility are machine flexibility of individual stations and range of flexibility of all stations. The next one is mixed flexibility, the ability to change different products while maintaining the production quantity. And the product flexibility, the ability to change different design changes with new products introduced. Next one is the routing flexibility. It is a capacity to produce parts through alternative station sequences in response to equipment breakdowns, tool failures and other interruptions. Next one is volume flexibility, the ability to economically produce parts in high and low total quantities of production given the fixed investment in the system. The factors that depends on this flexibility are level of manual labor, amount invested. The last one is expansion flexibility. The system should be easily expanded to increase the production quantity. The factors that depends on this flexibility are the expense of adding extra workstations and the ease with which layout can be expanded. There are 4 criteria for flexibility in a manufacturing systems. These are already discussed, and each test qualifies for certain type of flexibility in a manufacturing system. Based on number of machines, manufacturing systems can be distinguished. These are typical categories of the flexible manufacturing systems. The first one is single machine cell. Second one is flexible manufacturing cell, and the last one is flexible manufacturing system. Single machine cell. It consists of one CNC machining center with many part storage system. Each completed part are unloaded from the part storage unit and the raw materials are loaded into the CNC machine. The next one is flexible manufacturing cell. It consists of 2 or 3 processing workstations plus one part handling system. The part handling system is connected to a loading and unloading station through which the part reaches the storage and handling system. Last one is a flexible manufacturing system. It has a number of workstations connected to a common part handling system and electronically connected to a computer system which controls the entire process. These are characteristics of flexible manufacturing cells and systems. Depending upon the number of machines and the investment, production rate and annual volume. As the number of machines increases, the investment, production rate as well as annual volume also increases, which makes a flexible manufacturing system the highest in the order. Flexibility criteria applied to the 3 types of manufacturing cells. The system type single machine cell will have part variety, but the process is always sequential. It will never be simultaneous. The change of part is always scheduled, and error recovery is limited in case of single machine cell. In case of flexible manufacturing cell, part variety is there. Simultaneous production of different parts is also there. Then scheduled change is available. Error recovery is also limited when compared to flexible manufacturing system. Flexible manufacturing system, part variety is also there. Simultaneous production of different parts is also there. Scheduled change can be done, and error recovery is maximum when compared to other 2 systems. The level of flexibility. FMS is classified based on the level of flexibility into 2: dedicated FMS and random order FMS. A dedicated FMS is designed to produce a limited variety of parts, and the complete universe of parts to be made on the system is known as. Each and every part to be made through a dedicated FMS system is already planned before even starting the procedure. A random order FMS is more appropriate when the part family that is going to be produced is large. There are substantial variations in part configurations, new product designs introduced, engineering changes introduced, and the production schedule is subject to change from day to day. This is a comparison of both the type of FMS based on level of flexibility. Random order FMS have more flexibility and part variety when compared to dedicated FMS, but production rate increases with the dedicated FMS rather than random order FMS. Components of FMS. There are several basic components of a flexible manufacturing system: workstations, material handling and storage system, computer control, and human resource. Workstation. There are types of workstations found in FMS are loading and unload stations, machining stations, other processing stations, assembly station, other stations and equipment. Functions of the handling system are movement of the part between stations, handle a variety of part configurations, temporary storage, convenient access of loading and unloading parts, compatible with computer control. Material handling equipment is often shared between 2 systems. Primary handling system establishes the basic layout of the FMS and is responsible for moving parts between the stations in the system. It is basically a conveyor that handles the equipment from one system to other. Then secondary handling system consists of transfer devices, automatic pallet changing and similar mechanisms located at the workstations in the FMS. The function of the secondary handling system is to transfer work from primary system to the machine tool or other processing station and to position the parts with sufficient accuracy and repeatability to perform the process. There are certain configurations in FMS layout: inline layout, loop layout, and rectangular layout. The next one is computer control system. This system controls all the other 3 components: the workstations, material handling and storage, and other hardware components. A typical FMS computer control system consists of a central computer and microcomputers. Microcomputers control individual machines and other components, while central computer coordinates all the workstations and activities done by the workstations. The last component of an FMS is human resources. Labor are needed to manage operations on an FMS. Functions typically performed by human includes loading of raw materials into the system, unloading finished parts from the system, changing and setting of tools. If there is any tool repair, changing of tools is necessary, and equipment maintenance and repair, part programming if there is any in case of CNC, and operation of the entire computer system is based on human resources. Thank you.